Hello Year 5 and welcome to Week 5 Monday's Maths session. We're going to begin today with a little bit of mental maths work, and we're going to look today at finding fractions of amounts. So what I would like us to do is have a little look at the question in front of us today. We've got what is 1/3 of 12, and you can see here in my bar model I have 12 counters. And what I'm going to need to do, if I'm looking to find 1/3, I'm looking to break my whole bar into 3 parts if I'm wanting to find 1/3 of my 12 here. So what I'm going to need to do then, in order to be able to find 1/3 of 12, is I'm going to need to take my 12 counters and I'm going to need to divide them between the 3 bars. So if I do that now, so we've got 1, 2 and 3, 4, 5 and 6, 7, 8 and 9, 10, 11 and 12. If we take 1/3, we can see here that 1/3 is equal to 4. So the answer is 4. So 1/3 of 12 is 4. Now let's have a look at the next question. This time we're looking at what is 3/4 of 12 with our question mark on the end there. So this time what we're looking to do, we're looking at that denominator again, and we're thinking about how we can divide our 12 into 4 equal parts. So this time I'm going to divide my bar into 4 equal parts because there are 4 parts to the whole. So my first step is to divide my 12 into the 4 parts. So I'll do that now. And so what we can see here is in one of our quarters, here, in one of our quarters of 12, we've got 3. But we're not looking for 1/4, we're actually looking for 3/4. So we need 3 lots of 1/4. So we're going to take our 3 that we've got here, and we're going to need to multiply it by 3, which gives us 9. And we can see this here, 3/4, 1, 2, 3/4, makes altogether 9. So a reminder then that when we're finding a fraction of an amount, the first thing we need to do is to divide by this bottom number, this denominator. That's our first step. And then our second step is to multiply by the numerator. That's our second step, the top number. So the next question then, what is 2/6 of 24? Well, we take our whole 24, and the first thing we're going to do with our 24 is we need to divide by the denominator. So we're going to divide by 6. So let's split our bar into 6. And 24 divided by 6, well, I know that 6 times 4 is 24. So the answer will be 4. And then my second step is to look at, well, how many 6 do I need today? I actually need 2 lots of 6. So I need to take my, when I say 2 lots of 6, I mean 2 sixths. Okay, so I need to see what 1/6 is, which is 4, and I need 2 of them. So I'm multiplying by the numerator, which gives me the answer of 8 there. So divide by the bottom, multiply by the top. Let's look at this next one. What is 3/7 of 35? Well, here's my 35, and this time the first thing I need to do is divide 35 by 7. If we know our 5 times table, we'll know that 5 times 7 is 35. So if I split my bar, 2, 3, 4, 5, 6, 7, if I split my bar into 7 parts, each 7th is worth 5 today. And then my second step then, how many lots of 1/7 do I need? It's 3. And 1/7 is worth 5, so we're looking at here 3 times 5. Divide by the bottom number, multiply by the top, gives us the answer of 15. So what you're going to do now is you're going to pause the video and you're going to have a go at one of the challenges from, when I say one of the challenges, you're going to choose a column and those are the challenges you're going to have a go at for us. If you pause the video, as the answers will be on the next page. If you wish to draw bar models like I've done to model the problems, you can do. If you're now becoming quite confident with doing these calculations in your head mentally, that's absolutely fine as well. So here are the answers for you to mark. So our main session for today then, we're going to be looking at calculating with negative numbers. So our learning objective today is, can I understand and calculate with negative numbers? In order to be successful, you're probably going to need to use your knowledge of number bonds to help you and use your knowledge of addition and subtraction. And I'll just lift that up a little bit as we missed the last one off the end there. And also a number line is going to be a really useful model in order to help you calculate accurately today. So the first thing I'd like you to do is pause the video and I'd like you to have a go at ordering these numbers from largest to smallest and see which do you think is the largest down to which do you think is the smallest. Okay, let's have a look at those answers then. So you can see we've got 25 as the largest number here, then 12, then 7, then 1, then 0. I know to this point that we would be very confident with knowing that. The problem comes with these numbers. What might surprise you is actually minus 14 here is the smallest number. And that is because when we are working with negative numbers, the further away that number is from 0, so imagine our minus 14 is about here on that number line, the further away a negative number is from 0, the smaller it is. That's the opposite when we're talking about positive numbers. The further away a positive number is from 0, the larger the number is. Now you've probably seen some negative numbers before, you hopefully are quite familiar with those, and those are numbers that are less than 0 on the number line. Where we often see negative numbers is sometimes this time of year on a cold day on a thermometer chart. The colder the temperature, the further away the negative number will be from 0. The warmer the temperature, the further away the positive number will be from 0. And that's how negative numbers work. And we can see that on these two types of number lines. We've got a sort of standard number line that we work with in maths usually. And you can see from here, we've got this thermometer that's often used when we are measuring temperatures. And we can see the further away from 0 those negative numbers are, the colder it will be, the smaller the number will be. So today we're going to be calculating with negative numbers, and this is where you may be needing to use number lines to help you. If you can do this in your head or on empty number lines, which I'll be showing later, absolutely great. So you're going to start with the number minus 3. It says here minus 3 add 6. So when we're adding, we're obviously adding to the number, so we're getting larger, we're moving right along the number line. We're going to add 6, so we're going to say 1, 2, 3, 4, 5, 6. So our answer then is 3, a positive 3, not a minus 3, a positive 3. And the next one then we're going to look at is we're going to have a look at doing this one on an empty number line. So this time we're not going to jump in steps of 1. If you would prefer to jump in steps of 1 on the number lines in front of you, maybe with your finger, that's absolutely fine. Now I'm going to show how we can add on a number line but it being empty. So it says here we're going to add 19. Now when I'm adding from a negative number, the first thing I want to do if possible is I want to try and get to 0. So if I think about how many away is minus 12 from 0, well it's 12. So I'm going to add on 12. So from my 19, I've already added on 12. If I think about partitioning 19 into 12, it would be 12 and 7 because 12 and 7 makes 19. So I've started on minus 12, I've added 12 to get to 0, but I still need to add another 7 from 0 to get to my answer. And if I'm on 0 add 7, the answer is 7. So we can see that one there. Let's just do a second example. This time let's start on minus 10, and this time let's add 17 to minus 10. So I'm going to draw my number line, my empty number line there. Okay, and I'm going to start on minus 10. Now I know I need to add 17 altogether, but my first job is going to be to get to 0. So how many do I add to go from minus 10 to 0? Well, I add 10. So if I think about my 17 and partitioned it into 10, how much more have I got to add? It's another 7. Oh, didn't do that on purpose, year 5, but we actually found it's the same answer. Okay, so that's how we can use an empty number line compared to a structured number line where you can do jumps of 1 if you wish. So that choice is yours when you come to your work today. Now we're going to look at subtraction. So this question is asking us to begin on 5, and we're going to subtract 8. 1, 2, 3, 4, 5, 6, 7, 8. So my answer there then is minus 3. I'm now just going to model that, for those of you, on a blank number line. Now this time we're subtracting, so it's asking us to start on 5, and this time we're going to subtract 8. Very similar to when we're adding, we want to get back to 0. That's our first jump. So we're going to subtract to start with 5. And if we think again about the number 8 and partition it into 5 and 3. So we've taken away 5, that got us to 0. 0 take away another 3, so we've taken away 8 altogether, is minus 3. So we've got the same answer there. It's very important that we use that minus sign to show our answer clearly so it doesn't get confused with being a positive 3. And a second one on a blank number line, this time we're being asked to start on 9 and subtract 14. So my first job is to get to back to 0, so I'm going to subtract 9 to get to 0. If I think about the number 14 and partition it into 9 and 5, 9 add 5 will make 14. So then I need to subtract another 5, which gives me the answer of minus 5. See that minus sign there. So today then guys, what you are going to be doing is you're going to be working through calculating, adding and subtracting and working with those negative numbers. Use those blank number lines if you feel quite confident. If you want to, you can obviously draw yourself those 1 jumps on a structured number line if you wish, and you'll see those on your sheets of paper. Some of you might like to challenge yourselves to start trying to do this in your head as you think about using those bonds and that partitioning knowledge to help you calculate. We look forward to seeing your work. Thank you very much.